In this section, we're going to look a little bit more about negative arguments. So here we've got a complex number which is minus 3i, and let's try and work out what the modulus and argument of this complex number is. Well, the modulus of minus 3i is just the length of the vector from the origin to the point. So basically, how far away is the point from the origin in a straight line. So hopefully that's quite obvious that that's a length of 3 because we've just gone down by 3. The argument is a little bit more complicated. Remember, the argument is measured from the positive real axis. So we're measuring our angle from that green line there. And if we turn in that direction, then that's positive. So anti-clockwise is positive. And if we turn in the clockwise direction from that green line, we're turning in the negative direction. So one way of referencing where this point would be to go in the negative direction by an angle of pi over 2. So one way of saying the argument of this complex number would be minus pi over 2. Minus because we've turned clockwise from that green line. Well, you might have noticed already that there's another way of referring to where that point is, to what the argument is. Another way of referring to that argument would be to say, well, actually, you could turn in the positive direction by an angle of 3 pi over 2. So it would be perfectly fine to say the argument of this complex number is 3 pi over 2. And that's fine, but what we really want is we want a method where one complex number only has one argument. And in fact, there is a way of doing that, and it's called the principal argument. So the principal argument of a complex number, we make sure that the argument of the complex number is less than or equal to pi and greater than minus pi. So basically, we don't want the absolute value of our argument to be more than pi. We're not allowed to turn an angle of more than pi. So with this principal argument, let's work out where we can get to with a positive argument and where we can get to with a negative argument. So if the argument's positive between 0 and pi, we're going to be able to get anywhere in this quadrant or this quadrant as well. So if we're turning in the positive direction between 0 and pi, we can get anywhere here. So for example, if I had my complex number here, then I would turn in the positive direction by that angle there. With the negative argument, so between less than 0 but greater than minus pi, what we're going to do is we're going to spin in the negative direction, but no more than pi. So we can get down here, or we can get into this quadrant too. So for example, if we had a complex number down here, then what we're not going to do is we're not going to spin in the positive direction all the way around like that, because that would be greater than pi. Instead, we're going to spin in the negative direction like that, negative, to get to that complex number. Now, so any complex number in this yellow region is going to have a positive principal argument, and any complex number in this green region is going to have a negative principal argument. And that's going to ensure that the argument is never, you never have to turn an angle more than pi. You might have noticed that this says that argument of z is less than or equal to pi, but strictly greater than minus pi. That's to avoid confusion if you've got a point that's on the negative real axis. So, for example, if you had minus 6, then we could either spin in the positive direction by pi or in the negative direction by minus pi. But in order to avoid that ambiguity, we're always going to spin in the positive direction by pi. So to get to that point there, we're going to spin in the positive direction by pi to get to that point there. So let's have a look at example 5. So we've got this complex number. Let's sketch it in the Argand diagram. And we've got a real part of -4 and an imaginary part of 1. So we've got our point there. And this, we've called it point Z, complex number Z. So let's work out the modulus and argument then. So to work out the modulus, we're always going to use Pythagoras. The modulus of Z, well, we've got a right angle triangle here. And I'm just going to carefully label in these points, these lengths. This length on our right angle triangle is 4, and this length on our right angle triangle is 1. So using Pythagoras, we can work out the length, which is this length here, which is going to be the square root of 4 squared plus 1 squared, which is root 17. So that's the modulus of Z. Well, we also need to find out the argument. So remember, we start measuring the argument. This is our 0 angle along that line. And we need to say, well, what angle do I need to spin from that green line to get to this black line for Z? Let me just put in the direction. That's a positive direction, that's a negative direction. Well, because we don't want to use an angle more than pi, what I'm not allowed to do is I'm not allowed to spin this green line around in the positive direction, because I'd go past pi. It'd be pi plus a little bit extra. So I'm going to use the principal argument and I'm going to move in the negative direction. So I basically want, what is that angle there? Let's call that angle alpha. So in order to find alpha, I'm going to use this right angle triangle. I'm going to find this angle theta first and then do pi minus theta. So to find theta, I'm going to use tan. I know that tan theta, and this is where it's really important that you label your right angle triangle correctly. A lot of the time you see people get these 1 and the 4 mixed up, which is why it's really important that you draw a good diagram. So opposite theta is 1 and adjacent to theta is 4. So we can work out what that is. And remember, we're working radians, so it's 0.2449 ... And then to find alpha, I'm going to use the unrounded value, and I'm going to do 180 minus theta, or pi minus theta, because we're working radians. So pi minus theta, and we'd get alpha is 2.896 ... Well, we want it to 2 decimal places, so 2.90. So now we can write down what the argument of Z is. So we're turning from the green line, from the positive real axis. We're turning by an angle of alpha. So it's 2.90 to 2 decimal places. But we're turning in the negative direction. So it's going to be minus 2.90. It's worth just taking a look at what you would use if you weren't using the principal argument. If you weren't using the principal argument, then you would be allowed to say that actually the angle of this complex number, the argument of this complex number, is that angle in the positive direction. And that angle would be 2 pi minus alpha, 2 pi being the full circle, 360 minus the angle, 2 pi minus the angle. And that would be fine, and that would be a positive angle, but that wouldn't be in the principal argument. So this would not be the principal argument. So most of the time, if the question doesn't say it, we're going to use the principal argument.